Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is the answer. We are going to examine a question as usual in the recent posts. And the question is test-driven development actually difficult to learn? The prompt from this question comes from a conversation on Mastodon, where Emily Bache started with this. TDD is actually easier than writing the tests afterwards, so why is it so hard to learn? This is a quote. I was chatting with somebody at MyConf last week, and they came up with that statement. I'm kicking myself now for not asking them to elaborate. I have some ideas, but I'm interested in what everyone else thinks. In what ways is TDD easier than test after, and why is it hard to learn? And I answered by saying, my hypothesis is that TDD is only difficult to learn because we are learning programming as a linear process. And I think this deserves a little bit more details. So let's get into it. First of all, the TLDR, as you probably have seen, the problem is not so much learning test-driven development. The problem is unlearning the way you've been thinking about software development. And I'm going to explain this in more detail. But this is your short version. If that's enough for you, thank you for watching. If not, let's move on. I have been specialized in the past 10-15 years on delivering learning programs that change mindsets. So it's not only about people learning a specific technique, but it's also about getting them convinced, helping them, getting enough arguments. I'm not convincing them, but I'm helping them see the world of software development from a different perspective. And no matter which type of course I do, for example, we do one that is on secure coding. In that learning program, what we do is we show developers, we show programmers the extended world of security on what it means and how hackers think and so on, before we move on into actually defending. And so this gives them the necessary context to become slightly more paranoid. We don't want them to become as paranoid as a security expert, but slightly more paranoid, just enough to examine the code that they write, also from the perspective of potential security threats. And this is one of the recent examples where we work on the mindset as well as the techniques themselves, because of course with secure coding you have a bunch of techniques that you learn and a bunch of technical stuff and so on. But the mindset is the important part because that drives everything. And with TDD we noticed the same problem. So when people were learning test-driven development, it wasn't so hard to actually do the steps, right? Because it's not that hard to write a test, see it fail, implement code that passes the test. It's actually quite trivial to do all these things. There's a bit more with refactoring, where you need to have a better understanding of software design and so on, but that's a very interesting conversation, and at least two very interesting conversations. But the biggest problem is that people think, and programmers tend to think in terms of, this is a problem, let's figure out what the solution is, let's write down the solution. And I don't think this is because it's something native to programmers. I believe this is because this is how we learn programming. So if you look in every book, in every programming book, if you go to university courses, what do they teach you? They teach you this is the problem we are trying to solve. This is how this programming language solves it, cycles and whatever. This is the problem we are trying to solve. This is the algorithm for solving it, sorting a list. Okay. So because of this, we end up with this mindset that you get a clear problem, and that clear problem will turn into a clear solution. And this is completely wrong, because in most software development, what we get is an unclear problem that we need to make do, but we also need to surface our assumptions about that problem. We need to take that problem apart, and we need to figure out alternative solutions until we get to a solution that is the most appropriate, let's say, or the least worst solution. So because of this kind of thinking, which is very linear, right? You get a clear problem, you are expected to provide a clear solution, you end up with a linear mindset. And the biggest challenge in teaching, any kind of learning program or mindset change, is the unlearning. It's not so much the learning. So typically in our learning programs, one of the most difficult things that we try to achieve is to tweak very precisely cycles of unlearning and learning, unlearning and learning. Because this is also, I've seen it presented in many places as if you want to learn something new, you first need to unlearn the old thing, and then you need to learn the new thing. It doesn't work like this, because what you're dealing with is a semantic network, right? You're basically pulling in concepts and kind of digging at them, and then you try to replace them little by little with other concepts, but they still fit in the mindset of the individuals. And if you do this with enough of those, you end up with a new mindset. But you cannot do it too fast, and you cannot do it too slow, because if you're doing it too slow, it's boring. If you are doing it too fast, it's just people will get overwhelmed, they will get annoyed, upset, and natural barriers will start growing in front of what you are trying to show them. So instead, it's not a linear process, it's more of unlearning, learning, unlearning, learning, unlearning, learning. And maybe unlearning is not such a good deal, it's more like, let's look at this from this perspective. This is the usual perspective you're used to. And now let's just take another view from a different perspective. And let's see what this involves and where it takes us. And if we look from this perspective, we get this whole new mental model that, if reinforced with practice and answers to questions and so on, it has a chance of competing with the existing mindset. Okay, so I've explained a little bit about the mindset change. Now back to test-driven development. With test-driven development, as well as the other incremental and iterative processes, the issue, it's a larger issue in unlearning than it is in learning. This is what I noticed with our participants, with our learners. So basically, we need to encourage them to skip the point where they think in terms of linear solution, problem to solution, clear problem to clear solution, And instead of doing that, think in terms of, this is the problem, and let's now try to split this problem into smaller problems and not think about the solution at all. Let's avoid thinking about the solution. And you need to make an effort there. And that's part of the unlearning. And we do that, and then, okay, let's do one test. Let's do the second test. Okay. Now we are having some problems in the refactoring phase, and so on. So the process itself is not so difficult to learn. And why I'm saying that this process is, so it's not a natural thing to go from problem to solution, but it's more of a trained thing. I imagine that some people are more naturally inclined toward this type of thinking, while others are more naturally inclined toward a more incremental way. But honestly, it's very hard to tell. So my theory is that it's really a trained behavior. And imagine if you are learning from the very beginning a programming language with tests. So how would that go? And that's something I've done, and I've seen incredible results, but it's been on a very small sample size. So somebody wants to learn programming, they don't know a programming language. And instead of telling them, okay, this is how you write the main function, this is how you write cycles, this is how you write statements, this is how you open a file, whatever, the typical things. This is the language grammar. Instead of doing that, you can do it the other way, which is, let me show you how to write a test. And that's easy because it's a subset of the programming language. So basically you'd be writing something like assert sum of 2 and 3 equals 5. Okay, that's easy. It's a test. You run it, you see it's red. Okay, so now you have a point, a checkpoint, and you know, I don't know something because this test is red. And now I'm gonna go into the code, which is side by side. So you go into the code and say, okay, so how do we make this work? How do you think we make this work? And they would write like, okay, so it needs to be something like sum, or maybe I would write the function for them, the function, and then just say, okay, we just need to add body here. Write anything that comes to your mind that you think fits this. And they will write that, and then we compile, look at the compilation errors and say, look, it's fine, but this thing is not written like this in this programming language. This is how it's written. Pam. And you have a first statement operational, the use of operators. And if you know how to use plus, you probably know how to use any other arithmetic operator, because it's basically pretty easy. So, and you keep going like this. And then the test goes green and you understand, oh, I've actually learned something new. What did I learn? I learned how to write an expression based on operators. All right, let's move on. Let's do something else. And so on. Imagine you would learn programming like this. And imagine you would learn maybe the basic algorithms in the same way. So let's say you want to sort a list. Okay, let's start from a list with a single element. So if you have a single element, you expect, or empty list actually. If you have an empty list, you expect an empty list. If you have a single element, you expect that single element. If you have two elements in order, you expect two elements in order. If you have two elements in reversed order, you expect two elements in order. And so on. You don't end up with the best algorithm because TDD is not a method for creating optimal algorithms. But if you would learn the algorithm like this, it would be much more easier for a lot of people to figure out, oh, I have a method that I can use repeatedly in order to find a solution to a problem. And that's great. The only thing I need to do, besides the cycles, is to figure out how to split a problem into smaller problems. And that is the first step to engineering, right? Because what do engineers do? They take a big problem, they split it into smaller problems. Where they have equations and models that they can use, they use those. Where they don't, they need to invent something new and find their own solution. That's basically it. And in software development, we don't quite have models, kind of have with design patterns and some other things, but we're basically inventing a lot of stuff. And so this skill of taking a problem, splitting it into smaller problems, and then using tests to drive the implementation to the point where you have a solution that provably solves a clear problem is an excellent skill to have. And so this is where I believe the problem lies. The problem is not so much in learning test-driven development. The problem is in unlearning a linear model. The problem is to unlearn that you need to focus on the solution and to learn that you need to focus on the problem first or more. And I think that's one lesson that we've learned with every incremental process. It's the same with refactoring. It's the same with agile software development, right? Extreme programming, whichever flavor you want to use. But basically what it's saying, and that's how agile should be applied, is formulate a problem and then split it into smaller problems. And you can say that each of these small problems is a user story. That's basically what we do or what we should do. Now, I know that many of you get probably requirements baked into the user story, but in reality, my feeling is that we would be much better off if a user story would be a question instead of a statement in many cases. Okay, there are situations where things are very clear, like change the button color from red to green, whatever. Those are not that interesting, but the interesting ones might require or might be better served is if they are stated as a question and not as a statement. All right. Another thing. Okay, so the same problem applies to refactoring. And here, there's another thing that we need to discuss, and there's probably another hurdle for learning test-driven development. Test-driven development requires a belief, and it's a pretty useful belief. It's one that I've seen proven through examples again and again and again, but it doesn't have a formal proof. And the belief is that if we do these steps, split a large problem into smaller problems, for a small problem, write a test, then implement the code, then refactor. And if we do this for a longer period of time and for a more complicated problem, we'll end up with a solution for the problem. And the design will be simple. Okay, so there's a common question people ask at test-driven development workshops, which is, can we get stuck in this process? Because there's this uncertainty. We start, if you are thinking in terms of problem and solution, your assumption is that you know the problem really well, or you can understand it. And then based on that, all aspects of the problem will be transferred to the solution. Of course, this is not true because problems need to be small enough for our brains to remember everything. But this is what our reality, our common reality is. This is what we are used to. So with test-driven development, you are doing a leap of faith, right? And the leap of faith is, let this incremental model guide me towards the solution. It's almost like walking. So I know that I'm on a map and I'm starting from here and I know I want to get kind of here, but there's a fog and I have no idea if there's a road from here to there. And the assumption in test-driven development, which once again was proven again and again and again, is that you can get there. You will not get there on the straightest path always. You might need to do some turnarounds, but you will eventually get there. Okay? And now the next question is, are there any choices that you need to make in order for this thing to work, for you to reach your destination? Or, of course, programmer will ask, can you optimize this travel time? In terms of optimizing the travel time, very difficult to say. But there are some things that you can do that are heuristics and that apparently get you there faster. But it's very hard to measure it and say, okay, we actually got there faster. Unless you solve the same problem with different approaches. And what seems to be at least one heuristic that I found, there are more, okay, but I'm only gonna give you one heuristic. Each test should only add one more notion. And no more than that. At most one more notion. And of course, this is perhaps difficult to understand, but once you get into this process, you will start understanding that we have all these different notions that form together the problem. You already can see them from the problem, most often. Sometimes there are some hidden ones. But if you think about at every test is, what am I adding here? Am I going already on reinforcing something that exists, or am I going to add a new thing, a new notion? And strangely enough, the intuition of a notion in programmers is pretty strong. So this approach has worked wonders. Of course, there are more complex explanations. There's Robert C. Martin's transformation priority premise, which actually gives you a list of a priority for tests, an order in which to write the tests. But there are also some, let's say, course correcting mechanisms. And one of my favorites is, okay, let's say I'm writing tests, I'm in the middle of a problem, and now I'm writing a new test, and it fails, of course. But then I go into the code and I try to change the code, and I realize that I have to change a lot. I have to change some of the existing code. And by a lot, I mean, well, not necessarily a lot, but I need to change both things that are important for the past tests and things that are important for the new test, things that I need to add. And ideally, what I would like to have is just to write a line of code or a few lines of code, and that will sort out the new behavior that I'm trying to implement. And if this doesn't happen, then what I can do is to temporarily ignore the new test. So now I have everything green. Refactor the code towards a point where I can actually, I make room for the new implementation, and then re-enable the ignore tests, run it, I see it red, I write the new code, it works. So there are some course correct mechanisms, particularly if you believe you are making too many changes at once. This is a sign that you probably need to go into smaller steps, or that your design is not ready for this feature yet, for this behavior. And let me add one more thing. I've seen a common problem with people who criticize test-driven development, and that is they start by saying, oh, but error, it's much more complicated to write the unhappy path than the happy path, so let's start our test-driven cases with the unhappy path, and then you end up with a bunch of things that don't do much. They just check for errors. And that is, technically, it's possible to do it like this, but it's just not fulfilling. Okay. We want to see things working before we see things that shouldn't be working. So I prefer, and that is, I think it's purely psychological, because there's no reason it couldn't work. Test-driven development is just that it's annoying. Start by implementing the happy path and thinking about, okay, what is the essence of this problem? How can we split it, and so on? And then we go into the point where we ask ourselves, okay, so what can go wrong here? And in what can go wrong, I will add things like different values. If I have a string, pass the empty string, pass a very long string, pass a string with Chinese characters or accented characters or emojis, pass if it's a number, pass the maximum value, the minimum value, 0, because these are interesting values. They tend to create issues. If it's a daytime, pass different values for daytime, including 31st of December, including 29 February, 2024, or the next one, 2028, and so on. So we keep passing in all kinds of additional values. And also we pass in things like potential security issues. If it's a string, can I do any kind of injection here? Is that string used for something, in the database? What if I do semicolon drop database user? Does this work? Things like this. And then we write those cases in terms of when this goes in. Sometimes I just run them and I see what happens. And based on that, I would throw an exception or not. Or I would make a decision what to happen. What would be good in this case? If I pass this, what kind of exception to throw, or what kind of error code to return, and so on. So you can go into a lot of things, but start with the happy path because it's just more fulfilling. It's better to see something working first than a bunch of errors getting thrown. It's just human psychology. All right. So that's it for today. This is what I had to say about learning test-driven development. If you want to learn test-driven development, let us know. We have some, as I said, some very interesting learning programs. If you want to upgrade your test-driven development or the way you write unit tests, we also have learning programs for that. Or if you want to, get into the mindset of secure coding, which is more and more important nowadays, let us know. By the way, I'll be in Brescia in 1.5 weeks. I'll give a keynote there. So and I'll do a workshop on secure coding. So if you are from the area, let's get together. The conference is free. The workshop is not free, but it pays for our expenses with going at the conference. So yeah, I hope to see you there. If you watch this channel, I'll be happy to discuss and exchange some opinions during the conference day. Right, so what do you think about all this? Was it difficult for you to learn test-driven development? Have you tried learning test-driven development and went on a good path, on a bad path? How easy to apply test-driven development in your daily work? Let us know in the comments. We love comments. And we really enjoy that people are starting to like our videos and post likes. But we also appreciate and continue to appreciate open conversations. And if you have any questions, these questions might turn into a video. This is one of the perks of watching this channel. All right. With this being said, thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.